Today we're doing a lab on vibration analysis, another virtual blended lab during the COVID season here. And I'm going to turn this off a little at the moment. You'll notice that it puts a vibration out because we purposely put an off-center tool on that Dremel unit. And we use the Dremel because it's a common item, and it's also capable of running at about 20,000 RPM. What we're going to do here is create something similar to the University of Wisconsin vibration analysis done in their lab, where they're exploring what we need to do to figure out time before overhaul on major machinery, get a machine signature, and then hopefully figure out a way of predictive analysis that allows machine experts to repair the machine. This is really a mechanical engineering problem. We want to do that repair before something goes bad. So if we look at that screen over there, you're going to see that I did a printout, but let's take a look at it on my laptop, which is a little bit easier to see. And you can see that we did an overlay of the signature of this unit. So by putting a normal tool in there, we got that first dark red line. That's the smooth line you get from a smoothly running machine. And then we simulated a bearing or shaft failure with the off-center. What we want to do, though, is we want to be able to get enough feedback so we can do something called SCADA, Supervisory Control and Data Acquisition. And we want to get into the programmable sensor area and figure out how can we do this so that we know not only what it's doing, but the machine is going to have enough information so that it can tell us what's wrong. And that's where the DCU comes in. Because with the DCU, you can create your own programmable sensor, which is what we did here. And then we played with the set point on that sensor so that at a certain RPM, or in excess of a certain RPM, we're going to get such a nasty vibration, the type of thing you'd get before a failure, that it would alert you to the problem. But in a noisy environment, you may not be able to hear that. So what we're trying to do is we're trying to get some feedback that's going to tell us exactly what's going on, and it's going to trigger a signal using the DCU here for feedback. That very much is a similar process to what you find in programmable sensors, something using what we call SCADA. And what that does is it feeds the sensor to a programmable unit like a PLC, and that programmable unit in turn can either shut down a machine, send a signal to somebody on their laptop. There's all sorts of possibilities, but we can allow the machine to communicate with the real world and therefore prevent problems. So vibration analysis, we can certainly simulate it using Vernier, and there's a whole bunch of other options that you can do if you choose to do this as a lesson plan.